Right, Hooke's law, which is all about how things behave when they're stretched and squeezed. And in schools, they tend to do an experiment involving springs. Right, what you need to know is extension is the difference between the length of a spring as it is now and its original length. Okay, so we'll give you a couple of examples to make it a bit clearer. I've got a picture here of a spring. The blue thing's supposed to represent the spring, and you can see it's got no weight on it, and that is the original length from the top of the coiled bit to the bottom of the coiled bit. Don't include the straight bits because they don't stretch. And if you look now, we then add a weight to it, and if you notice it's now stretched, and what you do again is you just measure the distance from the top of the coiled bit to the bottom of the coiled bit, and the difference between the final length and the original length, that is the extension. So you can see I've put an arrow, a red arrow there with two arrow ends on it saying extension. So that's what we mean by extension. In this case, for example, the original length was 10 centimeters. The final length is 30 centimeters, so the extension is 20 centimeters. Normally in classes you do an experiment like this where you have a spring, you keep adding more and more load to it, and if you notice when there was 0 newtons on it, it had a length of 22 millimeters. And when you put 1 newton on it, it had a length of 42 millimeters. So can you guess as to what the extension is? Well, the answer is going to be coming now. The extension is 20 millimeters. Okay. Obviously, when there was no load in it, it wasn't extended, so it had 0 extension. But the way you got the extension was 42, take away 22, which gives you 20. And when you do this experiment, you'll get a table of results like that. And if you plot it in a graph, you get a lovely shape like this. It's a fantastic straight line for most of the part, for 1, 2, 3, 4, 5 newtons, lovely straight line. And when you take the weight off, it goes back to its original length. But after 5 newtons, if you notice, it suddenly starts behaving strangely. And this is known as the limit of proportionality. It no longer behaves in a predictable fashion. And indeed, at this point, you'll find that the spring has been damaged. It will not go back to its original length. And so that key point there, that point where it suddenly starts going a bit wrong, is known as the limit of proportionality. You need to make sure you know that in the exam. Extension up the left-hand side, load along the bottom. There is a law for this. This is given to you in the exam. Again, it's force equals spring constant times extension. The units of force is the newtons. The unit of extension is meters. And if you rearrange the equation, you would find that the units of spring constant are newtons per meter, or newtons over meters. This is maybe shown as F equals KE, F being the symbol for force, K is the symbol for spring constant, and E is the symbol for extension. And you can put it in a triangle like that. A couple of things you might want to know is that that spring constant is basically the force per unit extension needed to stretch it. If someone asks you what is spring constant, you can say force per unit extension. That is basically rearranging the formula in that triangle, F equals Ke. And also, the bigger the number of K, the stiffer the material. That's an easy card to make. You know, what does K mean? Well, the bigger the number, the stiffer the material is. Very often they'll have a question about the energy, and what you need to say is that the energy is stored as potential elastic energy, or elastic potential energy. Make sure you've got the word potential in there. So it's elastic potential energy, and of course when you take the energy stored in it can then be released as kinetic energy if you decide to use the spring a bit like a catapult. So talk about that the energy is stored in the spring as elastic potential energy. And that is everything you need to know about Hooke's law and springs.